Welcome everyone in this new video. In today's video, we'll be looking through arithmetics in Numpy. We'll go through basic arithmetics, absolute values, how we can calculate some trigonometric functions, exponents and logarithms in Numpy. So let's get started. Okay, so let's say I have x variable which is equal to np.array, and it is, let's use a range, and I need 6 elements, and we print x. So first we need to import Numpy. Import Numpy as np. So we get from 0 to 5. Fine. Let's say I want from 1 to 6, that is from 1 to 5. Fine. So there are a bunch of basic arithmetic operations like addition, subtraction, multiplication, division that you can obviously perform. Let's say x minus 5. Now basic operations which are performed are done element wise. That means if I do x minus 5 will be applicable for every element. We'll iterate over every element. So it will be 1 minus 5, then 2 minus 5, 3 minus 5, 4 minus 5, and 5 minus. Similarly, if I say x plus 10, so 10 will be added to every element. Same way, x times 2, every element will be multiplied with by 2. And let's say I want x divided by 2. Now there's one difference. This division is normal division. Okay. What it does, it divides everything by 2. So 1 divided by 2 is 0.5, 2 divided by 1, 2 divided by 2 is 1. Now if I say x divided by with double slashes and then 2, what it gives me is 0, 1, 1, 2, 2. What this means is this is a floor division. It gives you the integer value only. So over here 0.5, the integer value is 0. So I'll get 0 over here. 1 is 1, 1.5, the integer value is 1. 2.0, the integer value is 2. 2.5, the integer value is 2. So over here you can also see that data type is int 32. Int means normal integer values. 32 means in storage it's taking 32 bits of memory. Okay. Now there is also one modulus sign. What modulus does is it gives you the remainder. So x percentage, we use percentage as modulus. Let's say x percentage 2 will get 0, 1, 0, 1, 0. So it's like 1 divided by 2, 2 divided by 2, or 3 divided by 2. So absolute values are fairly very simple. Let's say I have variable x with np.array minus 2, minus 1, minus 3, 1, let's keep it minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay. Let's print x. Now if I use abs and x, what happens is negative numbers are converted to positive numbers. So let's say I do x minus 5. What I get some negative numbers over here. I get negative numbers, of course, because everything over here is smaller than, in positive is smaller than 5, and negative plus negative, negative minus negative, you add. So if I say abs 5, x minus 5, this is nothing but what you're saying is add 5 to everything. But if you notice, if you add 5 to 3, it will give you positive 2. Minus 3, it will give you positive 2, positive number 2. If you add it to minus 2, it will give you 3. Now over here we are not getting 3. What this means is it's basically adding the 5, it's basically performing this operation x minus 5, and then it's taking the absolute values over here. So 8, 7, 6, 5, 4, 3, 2, and so on. Moving on to trigonometric functions. Now trigonometric functions are also simple. Let's say we have theta is equal to np dot linspace, and over here I want from 0 comma to pi. Okay, so np dot pi, and I want 3 elements, and let's print 3. Let's see what we get. So very first element is 0, the second element is 1.57, and 3.14. What linspace does, if you don't know, you can watch my previous videos. I've explained linspace and many other numpy functions in that video. Moving on, we want to perform trigonometric operations. So let's say sine theta. np dot sine theta, of course. So it does the operations and gives you the result. Similarly, let's say np dot cos theta gives you the result, and np dot tan theta gives you the result. Okay. Now let's say you don't want sine, cos, tan, you want sec, cosec, or cot. Okay. So what you do is like you just reciprocal it. So whatever number you have got over here. So let's say 1 divided by, let's say you want cot. Cot is 1 divided by np dot tan theta. Okay. So you get cot. So there is 0 over here, so you can't divide by 0. That's why it's giving you this error. Um, let's say I want it from 1 to 5 3 elements, so we won't get zeros. And let's run everything else again. And let's print cot, and we get some answers. Similarly, sec is reciprocal of cos, and cosec is reciprocal of sine. So over here, let's write np dot cos theta. Let's print it as well, and cosec is 1 divided by np dot sine theta, and we'll print it as well. We get our outputs over here. Now moving on to exponent and logarithms. Okay. Let's say I have x as a list over here. Okay, not an array, but as a list. X equals to 1, 2, 3, and print it. And we write something like exp np.exp x. You get the exponent of every value in list. Now what if I want 2 to the power x, not x to the power 2 or x squared? I want 2 to the power x. You can use np.exp exponent 2 and x. So it is this x, it is 2 to the power this number. It's 2, and it's 4, and then it's 8. So on. What if I want a customizable number? Let's say I don't want exponent to the power x to 2 to the power x. I want 3 to the power x or 4 to the power. Or let's say I want something like 10 to the power x. What should I do? Well, there's a function called np.power. Okay, and what you do is you pass in the value, the value you want. You pass in the value, and then you pass in the array you are using. Okay, it will give you 3 to the power 1, 3 to the power 2, and 3 to the power. Fine. Moving on to logarithms. Logarithms are also very simple. Like let's use the same example. Well, let's make another. Okay, let's make 1, 2, 4, and 10. And let's say we print x1 first. Then we do something like np.log x1. Now normal log is log to the base e, which we also call as natural log. Let's say we want log to the base 2. What should we do? np.log to x1 and np.log 10 x1 for log base 10. Okay, fairly simple. So this is all for this video. Hope you learned something from this and you enjoyed watching this video. Thank you for watching. I'll see you in next video.